Let's take a look at the most unique feature of the Casio ClassPad 400. Go into the main. Let's clear out everything we have here. We'll clear out all the variables as well. The Casio ClassPad 400 allows you to link multiple screens together. So now no longer do you just have a calculating screen. You can also enter graph screen, y equals screens, y editors, geometry, spreadsheets, conics, functions. You name the screen, you can put them all together in one place. So for example, let us say we wanted to graph an equation, and we wanted to see what the graph of that function or that equation looks like. Start out by typing in your equation. We'll go up to the top. Y equals x raised to the second plus 3x minus 2. Execute. Nothing much happens there. If you would like to, you highlight, drag and drop to the lower screen. When you drop, you're going to get the equation show up along with the graph of the function. So now we can do things like we can G-solve, find the roots of that function, execute those roots to show them on the screen below. But also, above, we could actually solve for that equation. So if we come up here, go to Calculations, or Equations and Inequalities, and solve the equation you have for 0, equals 0, and we're solving for x, you get a representation of what the answer is. But more than that, now you have your zeros below on the graph, and you also have your equation solved above. So now we're starting to see connections between mathematics that we do to the graph that it represents. Let's say we wanted to pull together a geometry screen. We'll start out with a new geometry screen. And we'll do something very similar. Let's draw ourselves a triangle. Now if we wanted to know the equation of a certain part of the triangle, select that side, drag it above, and it gives you the equation. If you're studying systems of equations, grab a second one, drag it and drop it above, and you get your second equation. We can separate these. Or let's get a whole new representation of all three of these equations. We'll come up here and we'll delete everything. We'll clear all. And then we'll drag this entire triangle, one piece, two piece, all three pieces selected, drag and drop it above, and see what you get. You get a matrix representation of this triangle. So this triangle has vertices at all three of these locations. Let's say we wanted to change that equation, or that set of matrices, and then drag that matrix back down. You notice what the change has done. 2 out of the 3 were the same. The third point is now different, and you're getting a slightly different triangle. Tap above. We could also do this with conic sections. Let's clear all here. X squared plus y squared equals 7 squared for the equation of a circle. Select the equation of the circle, drag it, drop it below, and you have a graph of the equation of a circle. Let's add something to this. Minus 2x. Make sure we use the correct x here. Again, select it, drag it, and drop it. Now you get a slightly different circle. It's off-center. Let's choose a different type of equation or a different type of problem. Probability simulator. Gives you a probability simulator down below. Now this data can be shared between screens by simply selecting, dragging, and dropping to the screen you want to work with. Defining functions works very similarly. Let's go back to the main. Another place you can do this is what's called an e-activity. An e-activity is going to add a bonus in being able to connect geometry with regular algebra. So let's open up a geometry window that we will share with here. Looks very similar, except you have these bars. The e-activity link is actually a place where you can create lessons and have students work through lessons. It works similar to a slideshow presentation where each one of these bars will open up a different window. So currently this bar is opening up a geometry window. That's what you see down below. But if you wanted to, you could type in instructions on what students are to do at this point. Let's type in an equation like we did before. Y equals x squared minus 3x plus 2. Again, we'll just go ahead and select that equation, drag it and drop it below in the geometry window, and we get our representation. Let's turn in some grids. There we go. We're going to do something slightly different. We're going to go up top, edit, insert, what's called a geometry link. Now the geometry link, you see this chain link, will actually connect the graph to the equation above. So when you select the graph and drag and drop it above, it doesn't look much different until you start changing the graph's location. Drag the graph to a new location and drop it. Now your equation has changed. Drag it to a new location and drop it, and your equation changes. Or come above and make the changes on the top part of the screen and watch the change below. So now you start to explore what happens if I make it negative 3x squared, and what does that do to the graph? What if your graph is centered somewhere else? How is the center of the graph connected to the equation of the graph? This is a geometry window, so we can do things with systems of equations. We can do this with matrices. You can do this with vectors. Let's pull up vectors. So in the geometry window, I'm going to open up a vector. And we'll put the vector somewhere on the screen. Really doesn't matter where. Let's explore the vector. We'll select the vector. Make sure I'm dropping it into a clean space above. Just toggle down. Select the vector, drag it and drop it. When you get the blinking arrow, that means you're ready to go. So that vector has components of 4, 3. What do those components look like when you drag them back down? You'll notice that they're somewhere completely different from where the original vector was. The question is, well, how is that point for that end of that vector related to our original vector? Since we can interact, we can select the vector, drag and drop, and then realize that vector is in initial position. So the calculator has found the initial position of that original vector with one end at the origin and the second end, the arrow end, pointing to the point. So now you can do vector addition and subtraction using these same concepts. Let's take the equation of a circle. First, let's draw a circle. So we'll draw a circle down below. We'll select the circle. Let's find some clean space down here. Select the circle. Drag the circle to the top screen. Let go. Here we have the equation of the circle. Again, if we wanted a geometry link, let's input a geometry link. So we'll insert geometry link, drag and drop the equation of the circle, and change the 8. Let's just get rid of the 8. How does that affect the circle? Let's get rid of the minus 2y and change the end to a 5. centered at the origin, radius, square root of 5. Let's clean the geometry screen. And we'll clean the screen above. So we'll input our geometry window. Now this time let's do a system of equations. Let's use the keyboard, use a system, and we'll do a system of linear equations. Second equation. Toggle to the end. Let me get back to that point right there. Y equals negative x. We'll just go x plus 2. This will give us some intersecting lines, and we're going to solve for x and y. And currently, I'm writing instead of calculating, so now I've changed that to a calculating window. So now we get an answer. If it has just the A, that just means you're typing, so that's text versus a calculation. If you're not in a calculation, it won't calculate. Put away the keyboard. Let's drag and drop the system of equations that we got. We'll do this one at a time. We'll drag the first one, select the second one, drag and drop. Let's turn on our grid in the background. I'm going to adjust the window, so I'm going to just grab the hand tool and move my window so I can see my intersection better. Now I've got a visual representation of this system of equations. I can tell by the grid the solution should be 1, 3. Or, since I'm here, I'm going to find the intersection of those two by going up to my geometry tools, finding my intersection tool, select those two, intersection is at point A. Let's highlight point A. Point A has 1, 3, which is x is 1, y is 3. So again, we have a visual representation of a system of equations. And if we had had a geometry link here, we could have made changes to those two equations and watched how these two interact. Let's select above again. You've got other options as well. Slope fields, statistical graphs, functions, regular calculations, the solve, which is your function solver, again, conic sections. Anything you want, you can put together in 2 screens.